Okay, optimization part 4. In the part 3, we reached that we did an equation and we did its derivative, taking this equation equals 0 according to time, right? So it's x over 6 radical 6 plus x squared, taking minus 1 over 10 to the other side, it will be 1 over 10, and we multiply both sides, right? 10x equal cross product 6 radical. It's not 6, this is 9. This number is 9, so 9 plus x squared dividing by 2, it's 5x equal 3 radical. 9 plus x squared, squaring both sides, it's 25x squared equal 9 times 9, 81 plus 9 x squared, and then we take x squared to the same side. 25 minus 9 is 16 x squared equal 81, then divided both sides by 16, we end up with x squared equal 81 over 16. This means that x equal radical 81 over 16, and that is x equals 9 divided by 4. And this is the only value. There's no negative value here. X is a number, is a numerical number, right? Distance. So we should have x as 9 over 4, right? This x should be 9 over 4, which is 2.25, and the rest from to have 5, she runs home. This will minimize, this point will minimize the distance as minimum as possible. Let's see. Let's do another example. Find the dimensions of the cylinder of maximum volume that can be fitted in a square of radius r. Maximum volume cylinder, and okay, we have a cylinder. Suppose I don't know how can I draw this? Let me try. This is a cylinder. Okay. I need to find the maximum volume of this cylinder that can be fitted inside a sphere, right? Suppose this is a sphere. Okay, that's good. Let me do this. Okay, so we have a cylinder inside a sphere. Okay, what is the radius? All right, if we have volume of the cylinder is pi r square h, but we don't need to have two variables here. Instead of having these two variables, let's say this is the radius of the cylinder, and from the radius of the cylinder to here, this is half the height of the cylinder, half the height of the cylinder. What left is this, which is the big R, the radius of the sphere. That's nice. Radius square is equal to height over 2 square minus r plus r square. Let me find how much is r in terms radius square equal r square minus h square over 4. So what will be r equals to? It will be radical r square minus h square divided by 4. This is small radius in terms of big radius of cylinder in terms of radius of the sphere and the height of the cylinder. That's great. Volume, now we can substitute instead of r its value, so it will be pi r square h. R square, this means this r square minus h square over 4 times h, right? So it will be equal to, this will be equal to volume of the cylinder will be equal to pi r square minus pi over 4 h cube, right? H cube. The height of the cylinder will be for sure positive, or maximum it will be the diameter of the sphere, which is maximum value can cover the diameter of the sphere. Otherwise it will be outside of the sphere. We need it to be inside the sphere, so 2 capital radius. Okay, now let's find the derivative of this volume. What is the derivative of this volume? Pi r square h, pi r square h here, huh? Pi r square h. We have to derive. Let's we consider that r square, r, the big R, capital R, is a constant number, so it's pi r square minus 3 over 4 pi r square, right? We are deriving in terms of variable small r, small h, I mean. This is h square. Okay, so taking the volume equals 0, taking the volume equals 0, this makes that pi r square minus 3 over 4 pi h square equals 0. This means pi r squared equal 3 over 4 pi h squared. Can we find h in terms of r? Cross product, 3 pi h squared equal 4 pi r squared, dividing both sides by pi. Let's divide both sides also by 3. So the answer will be h squared is equal to 4 over 3 r squared. And h is a positive value we said. This means h is equal to positive 2 radical 3 over 3r. Okay, we do radical for the other side and we simplify and we rationalize. We end up with 2 radical 3 over 3r. Okay, let's do. We have 0, right, a critical point and a point. We have 2r and we have a point between them, which is 2 radical 3 over 3r. Finding each one of them, v of 0, we will have 0, you can substitute it. V of double r is equal, it will be equal to 0 also, you can substitute it and guess that. V of 2 radical 3 over 3r will be equal to, after substituting in the original volume, we get, after simplification, this value, which is, let me substitute it in the original equation. Volume of 2 radical 3 over 3r. Where's the volume? Volume is pi. Let's substitute it in this one, right? Let's substitute it here. Pi r square h minus pi over 4 h cube. Okay, pi r square h, this is h, the height of the cylinder, minus pi over 4 h cube, 2 radical 3 over 3 r cube. That will be equal to 2 radical 2 pi radical 3 over 3 r cube minus we cube this value here and we end up with 2 pi. We end up with value, this is 2 cube is 8 divided by 4, it's 2. Pi will be pi, this is 3 radical 3 after cubing it over 27, so it's radical 3 over 9, and we still have r cube. And the final answer after multiplying this with 3 over 3, 6 minus whatever, 6 pi minus 2 pi, we end up with 4 pi radical 3 over 9 r cube. And this is the maximum value where h is 2 radical 3 over 3r and the volume will be 4 pi, because here it gives us 0, same 0 volume, and the maximum value we can attain is where h equal to radical 3 over 3r. And what is r? R is equal to radical r squared, that's what we did in the beginning, minus h squared over 4, substituting instead of h its value here 2 radical 3 over 3r, we got a final result as radical 6 over 3 of the radius of the sphere. Okay, see you next video.